Okay, so in this section, we're going to talk about 6.1, which is discusses the natural logarithm function. So to kind of start us off with, let's say we have these particular terms, all right, we want to take the derivative of. Okay, so we want to take the derivative of these things, these terms here. Okay, so when we take the derivative of this, right, x squared over 2, that's just going to be 2x over 2, which gives us just x, right? When we take the derivative of this, the derivative of x, that's just going to give us 1, right? Because this is a power 1. Um, when we take the derivative of this one, what we can do is we can raise the x, right? So we can rewrite this as -1 x to the -1. And when we take the derivative of that, that's going to give us a -1 times -1 x to the -1 minus 1, right? So that gives us a positive x to the -2. All right. And same thing for this one, right? I can bring out that 1/2 in the front. I have a -1. When I take the derivative, that -2 will go in the front there. And I can subtract 1 from the power. So these twos will cancel. The negative becomes a positive. So this gives me x to the -3. Okay. All right. So we know how to do this. So can we find a term that when we take the derivative of it, right, produces um, x to the -1 power? Can you think of a term when you take the derivative of it produces x to the -1 power based on what we are doing here? All right, so another way I can rewrite this is x to the -1 is I can rewrite this as 1 over x. All right, so as we think about this, right, we're trying to figure out whether there is a term that we can take a derivative of our function that it produces 1 over x. In this case, there's nothing, right? There's no x term that I can do that will produce this. Okay, so this is where um, the natural log comes into play. All right, so if you think about this, so the natural log is ln of x, right? And um, back in Calc 1, we talked a little bit about the first fundamental theorem of calculus, where it says that, let's say we have the integral of from 1 to x, 1 over t dt, okay? And if we were to take the derivative, okay, so remember if we took the derivative of this integral, what happens? What does it become? So remember, as we take the derivative of an integral, they just cancel each other out. And so this produces just, as you mentioned, 1 over x, right? So this just becomes 1 over x because, again, the derivative and the integral here, they cancel each other out, okay? So this is where this comes into play. So when we take the derivative of ln of x, it is 1 over x. Now, one thing we have to keep in mind is another way we can write this is dx of ln of u, okay? Which means we need to consider the chain rule. So in this case, it would still be, the derivative of ln of u would still be 1 over u based off what we just did, but then we have to take the derivative of u, okay? So that would be times dx of u, all right? Or 1 over u times du over dx, okay? All right, so just keep that in mind that if there is something besides just x in there, we have to take the derivative of inside of that function, okay? So, and bottom line here is the derivative of ln of x is equal to 1 over x. Okay, so this one we want to take the derivative of ln of 3x to the third plus 2x, right? So if we apply the rule, okay, so this will become 1 over 3x to the third plus 2x, and then we have to take the derivative inside of that function, okay? So that becomes 9x squared plus 2. Again, we have to always consider the chain rule here. And then we can rewrite this as 9x squared plus 2 divided by 3x to the third power plus 2x. Okay? Sorry, that's good. All right, so again, we want to take the derivative of ln of the square root of 3x minus 2. One thing we can do is we can rewrite this, right, as ln of 3x minus 2, raise that to the 1/2 power, okay? So when we do that, we will get 1 over still the 3x minus 2 raised to the 1/2 power. Then we can take the derivative of the radical. So that's going to become 1/2 times 3x minus 2. And then the 1/2, that's going to be minus 2 over 2 or minus 1. So that's going to give us a negative 1/2. Okay. And then we have to take the chain rule again. All right. And take the derivative inside here, which is going to give us a 3. Okay. So then we just simplify this. So, um, so we get 1 over 3x minus 2 raised to the 1/2 times that by, I can combine the 1/2 and the 3. So that'll be 3 over 2. And then I can rewrite this here as 1 over, I'm just going to bring this 3x minus 2 down to the denominator. So that makes the negative 1/2 to a positive 1/2. So that's going to be 3x minus 2 raised to the 1/2 power. All right. Or I can rewrite it as 3x minus 2 and then 3x minus 2. Okay. And then I can combine those together. Right. So that becomes 3x minus 2 square, right? If I combine these two together. And so when I do that, the radical and the square go away. So then I'm left with 3 over 2 times that by 3x minus 2. Okay. Or some of you had distributed that, which is fine. Actually, this should be 1 over, right? So that'll be 3 over 6x minus 4. Or 3 over 6x minus 4. Okay. All right, so this one we want to find dy dx if y is equal to x squared times ln of x. So in this case, we need to use the product rule to find our derivative here, right? So this will be our, the derivative of this will be dy over dx. And then we're going to use first, the product rule first times the second derivative plus the second times the first derivative. Okay. So our first term here is going to be our x squared. And then our derivative, so first times second derivative, that's going to be 1 over x. The second term here is going to be ln of x. And then our first derivative is going to be 2x. Okay. All right. And then we just simplify this. So x squared times 1 over x, that's just going to give us x. Okay. Or x squared over x, which is going to give us x. And then here, we just bring this down. That's going to give us 2x ln of x. Okay. Let me erase this here. Right, and there's our answer. So we have x plus 2x ln of x. All right, so this next problem is we want to find dr dx if r is equal to ln of x over x squared times ln of x squared plus ln of 1 over x raised to the third power. All right, so we want to take the derivative of this term here or terms here. So we want to find dr dx if r is equal to ln of x over x squared ln of x squared plus ln of 1 over x raised to the third power. As I mentioned, I like to kind of break this down into parts to make it easier to simplify or solve. So the first part here is we're going to take the derivative of this first term, and we have to use the quotient rule. And within the quotient rule, as you notice, we will have to use the product rule as well. All right. So again, we have denominator times numerator derivative minus numerator times denominator derivative all over d squared. So that's going to be the quotient rule. So in this case, we're going to have dr dx is equal to the denominator, which is going to be x squared ln of x squared. Again, this is just one way. You could have done it a different way, and that's totally fine. Okay, as long as the math, the steps you took are correct. So the denominator times the numerator derivative, so that's going to be ln of x, which is going to be 1 over x, minus the numerator, which is going to be ln of x. And then you have to take the derivative of the denominator, so you need to use the product rule on this. So that's going to be the first times the second derivative. So that's going to be 1 over x squared. Then take the derivative of x squared, which is going to give us 2x, plus ln of x squared times that by, so that's the first times the second plus the second times the first derivative, which is going to be 2x. Okay. So that's what we have for the top part. And then we're going to take all this and then divide that by d squared, which is going to be x squared ln of x squared squared. Okay. All right. So I'm going to work out, of course, we still have this part here I haven't taken derivative of, so why don't we do that? I'm going to put that on the side. So take this here. Like I said, I'm going to do this in parts. Okay, so when we take the derivative of this, okay, so take the derivative of this. Just like that, y. So y prime, that's going to be 3 times ln of 1 over x, and that's going to give us a power of 2. Then we take the derivative of the inside, right? So this is going to be 1 over x, correct? And then we take the derivative of 1 over x. So 1 over x is equal to x to the negative 1. So the derivative of that is going to give us negative 1x to the negative 2. Okay. All right. So in this case, we're going to multiply this by negative 1 times x to the negative 2. All right. So let's simplify this a little bit. So we're going to have 3 times ln of 1 over x squared. And then I can flip this, right? 1 over 1 over x. That can just be x, correct? Right? So, and then this part here, I can rewrite this as negative 1 over x squared. Okay? All right, so notice now that I can cancel one of the x's here. So this x can cancel with this x here, right? So we'll have one x left over here. So then this becomes 3 times ln of 1 over x squared times that by negative 1 over x. Okay. And again, we can rewrite this as 3 and then times that by ln of 1 over x squared divided by x. And then don't forget the minus in front. Okay, so here, so again, now we want to tackle this, um, the first part here. So I'm going to break this down into other parts. So I'm going to work on the numerator and then we'll work on the denominator. Okay, so for the numerator, so notice that, let's see here. I can get rid of the x squares, right? So these x squares here, I can get rid of. So I have 2x plus 2x ln of x squared, okay? And again, this is being multiplied by minus ln of x. And then notice here also I can get rid of the x here, and I have one x left over. So that gives me x of ln of x squared, okay? And then I'm going to distribute this ln of x to each term. So that gives us ln of x, 2x, but I'm going to put the 2x in the front, if that's okay, plus, going to have, I'm sorry, that's going to be a minus, right? So minus ln of x times that by the 2x times ln of x squared. Okay, so now what I can do is I can, well, let me pause this for a second. All right, so the way it stands right now, we really can't do anything. But what we can do is we can use our log rule. So whenever, if we have a x squared, right, we can put that power to the front. So this becomes 2x ln of x, all right? So it's the same thing for this one over here, all right? I can rewrite this as 2 ln of x, okay? So when we do that, so let's see here. We have 2x ln of x minus 2x ln of x minus ln of x times that by 2x times that by 2 ln of x. So notice that I can combine these guys together and then combine these guys together. So that's going to give me 2 times 2x times that by ln of x times that by ln of x. Okay? So this is going to give me a minus 4x. Okay? And then these guys, that's going to give me 2 of those. Okay? So this is going to be ln of x raised to the second power. Okay, so that's different from ln of x squared. All right, so this represents that I have 2 of the ln of x. Okay. All right. And then over here, what happens? Well, we got 2x ln of x minus 2x ln of x. So that just cancels, doesn't it? So this whole numerator just becomes negative 4x ln of x squared. Okay. So that's what we get for the numerator. Now let's look at the denominator here. Okay. So let me use a different um, color here. So we just Okay, so the denominator we have x squared. We have x squared times ln of x squared raised to the power of 2. Okay, so what we can do is we can square the x squared, which becomes x to the fourth power. And then what we can also do is, actually, before we do that, let's simplify this a little bit. So we have x squared times, I'm going to move this 2 here to the front. So it'll be 2 ln of x. Okay. So this is raised to the second power. So now I can do x fourth times that by 4 ln of x squared. Okay. All right. So again, I'm just squaring each of the terms. So that's how we get for the denominator. Okay. So now let's put that together. So for the numerator, so again, let me use a different color here. So for the numerator, again, we got, I don't know why it keeps doing that. Okay, so for the numerator, we got negative 4x ln of x squared. That's for the numerator. That's what we got there. And then for the denominator, we're going to swing that down here. That gives us x to the fourth um, times out by 4 ln of x squared. Again, I haven't forgotten about this, shoot, this part here. And I haven't forgotten about the what we did for the ln of 1 over x to the third. But anyway, so let's go ahead and simplify this. So notice that when we simplify this, um, the ln of x squared, these guys here are going to cancel. Okay. What else is going to cancel? Well, the 4s are going to cancel. Okay. So this leaves us with negative x over x to the fourth. Okay. And then this x is going to cancel, leaving us with 1, and then we'll have 3 left over on the bottom. So we get negative 1 over x to the third power. Okay, so that's what this side here is going to represent in regards to the derivative. And then we just combine it to what we had for here. Okay, so let's go to that. All right, so for the second part, we got this here. So, so our final answer is going to be negative 1 over x to the third minus 3 um, ln of 1 over x raised to the second power over x. Now, we do have a little, it might not take this answer because we have this ln of 1 over x. So if we try to type this in the lab, and it might not take it. So what we need to do here is we need to simplify this a little bit further. Okay, so what do I mean by that? So we have ln of 1 over x, right? So what we can do is we can expand this to ln of 1. So this is one of the log rules. ln of 1, since this is being divided, we can do ln of 1 minus ln of x, okay? So ln of 1 here becomes 0, and we have minus ln of x, okay? So, and so in this case, we'll have, let me pause this for a second. All right, so we get minus ln of x, so I'm going to replace ln of 1 over x as negative ln of x, and then this is being squared, all right? So then that negative there will just become a positive. So again, so we get negative 1 over x to the third minus 3, and then ln of x squared. So again, that negative, that would be a negative 1 squared, which becomes a positive. So that's why I rewrote it from negative ln of x to a positive ln of x, and then that's squared divided by x. All right, and that is our final answer there.